Welcome, this is Black Lotus, your YouTube script kiddie, and in this video I am going to explain the changes I made to my previous project, the miles per gallon auto predictions, and why I made some of the changes I did. So in my previous video, I made this model and a GUI app to go along with it. Um, I read in the data into a pandas data frame, and I immediately started imputing or filling in the missing values for horsepower because there were several missing values. And the way I did that was I split it out the main data frame into smaller data frames by make and cylinders and found the mean value for the horsepower and placed those in. On its surface, that's not necessarily bad. However, I am using cross validation and not a simple train test split. And so by imputing the horsepower this early, I cause data leakage. Because in cross validation, it's going to split it when the cross validation is called. So, and also in addition to that, it's very space inefficient. So in addition to that, I could just go over to my corrections here. In addition to that, I use some feature engineering. So I called in my data to a pandas data frame. I immediately replaced the question marks with an np.nan value and corrected the data types. I then used the class iterative imputer to fill in my missing values based on the features that I am using. So displacement, horsepower, weight, and model year. I'm no longer using the make model, but that's okay because this uses a normal distribution to find out the closest approximation for those missing values. I also used a column transformer to use the filling the missing values, and then I passed through the remaining features. And for my feature engineering, I just tried out several things, but the one that worked the best for me was taking the natural log of the values and then scaling for the models that need scaling. So down for the actual pipelines, I removed the linear models because they were just performing poorly compared to the nonlinear models. For my random forest class regression, I used a pipeline for the column transformer and then the random forest itself. And for these, the models which need the scaled data, my multi-layer perceptron and my k-nearest neighbors regressor, I used a pipeline that consists of a column transformer, the function transformer, and the standard scaler followed by the models. Then ran tenfold cross-validation to get the results, and I'll just go ahead and run that to show you what the results were. My previous results for the multi-layer perceptron, which is the model that I ended up using, was had an adjusted R-squared value of about 0.73, and the random forest regressor was slightly worse at 0.71. And now without any data leakage and the feature engineering, the adjusted R-squared the adjusted R2 score for the random forest regressor is 0.72, so slightly better. And the multi-layer perceptron is much better at 0.75 with a regular R2 score of almost 0.78, which is, in fact, after looking and doing some research into the topic, not too far off from a gradient boosted tree. So this is not only not having data leakage, but is actually performing better than my previous model. So once again, just a recap, I am using an iterative imputer, a column transformer, and a function transformer in addition to all the other classes that I used before. I read in the data into a pandas data frame, did not immediately fill in missing values, just replaced the missing values, the question marks, with an np.nan. Then I set up my x and y, the scores that I want to use, the formulas for them. I set up my iterative imputer to fill in missing values, made a column transformer out of that, With some feature engineering, use a function transformer. And then the pipelines consist of either the column transformer and the regressor, or if it needs scale data, the column transformer, the function transformer, as well as a standard scaler. So those are the corrections I made for my previous project. I'm going to close this project out and just move on to my next project. I thank you for watching this video, and I hope you got something out of it.